Morning, dear students. Today I will just rewind or revise the previous class. Okay, so previous class we discussed about adsorption, adsorbent, adsorbate, and physical adsorption, chemical adsorption, etc. Okay, so today's class we are going to discuss about the factors affecting adsorption of gas on a solid. Okay, that means here gas is the adsorbate and solid is the adsorbent. Okay, so what are the factors affecting adsorption of a gas on a solid? Okay, so first factor is nature of gas. Okay, which gas is going to adsorb on the solid surface? Okay, easily liquefiable gases like HCl, NH3, etc. are easily adsorbed or strongly adsorbed on solid surface than hydrogen, oxygen, etc. Hydrogen and oxygen is not easily liquefiable gases. Okay, so easily liquefiable gases are highly adsorbed on a solid surface. Okay, for example, for that NH3, HCl, etc. Okay, then second thing is surface area of the adsorbent means solid. Okay, so surface area increases means what will happen? The adsorption will be increased. We know that already we done in last class. Okay, with increase in the surface area of the adsorbent or the solid substance, what will happen? The absorption of the gas molecules also increased. Okay, the next point is pressure. Okay, so we know the adsorption is accompanied with which one? Decrease in volume. Okay, so for adsorption what is happening? Volume is decreases. Volume of the gas molecules is decreased. That means if you are applying more pressure only, what will happen? The volume of the gas molecules decreased. Okay, so adsorption increases with increase in pressure according to which principle? Le Chatelier principle. Okay, then effect of temperature. Effect of temperature, we know adsorption is which process? Exothermic process. That means temperature is or heat energy is released. So the adsorption decreases with increase in temperature in the case of which one? Gas on solid. Okay, so mainly four factors are there. Which one? First one is nature of the gas. Second one is surface area of the adsorbent or solid substance. Then effect of pressure. Then effect of temperature. Okay. Next we are moving to very important topic. Okay, that is known as adsorption isotherm. What is that? Adsorption isotherm. Isothermal process means we know that takes place at constant temperature, right? That is known as isotherm means it is a curve. Isothermal process means it is at constant temperature. Okay, so here isotherm means what? It is a curve at constant temperature. Curve or plot at a constant temperature. So what is adsorption isotherm? Adsorption isotherm means variation in the amount of gas adsorbed on a solid adsorbent, okay, with pressure at constant temperature is given by a curve. Curve means like this, okay, is known as what? Adsorption isotherm. So simply we can say it is a variation in adsorption of gas on a solid adsorbent, okay, with the pressure at constant temperature is expressed with a curve. That is known as what? Adsorption isotherm. So how much variation in adsorption of a gas is taking place with the change in pressure at a constant temperature is given by a curve. That is known as what? Adsorption isotherm. Okay, so first adsorption isotherm is proposed by Friedrich isotherm. What is the Freundlich? Friedrich isotherm. And in 1909, Friedrich, the scientist, proposed an empirical equation. Empirical equation means the equation obtained on experimental basis. Okay, so Friedrich proposed an equation, empirical equation, okay, that gives the relationship between the variation in adsorption of gas on a given unit mass of a solid adsorbent with the pressure at a constant temperature. Same thing, this adsorption isotherm, same thing. Okay, so just we have to some sentence we have to change that. What is that? Friedrich adsorption isotherm. He given a empirical equation to give the relationship, to show the variation in adsorption of a gas on a unit mass of solid adsorbent with the pressure at constant temperature. Okay, so that equation gives an idea. What is that? How the variation in adsorption of a gas is happening on a unit mass of a solid substance. That means for a particular amount of solid mass with the pressure at constant temperature. Okay, so that expression is known as, or mathematical equation is known as Friedrich adsorption equation or Friedrich adsorption isotherm, or simply we can call it as Friedrich isotherm. Okay, so what is Friedrich adsorption equation? It gives the variation in adsorption of gas on a unit mass of solid adsorbent with the pressure, with the change in pressure at constant temperature. Okay, so what is that equation is x by m equal to small k. Kp raised to 1 by n. What is the equation? X by m equal to Kp raised to 1 by n. You have to know all the terms in this. Okay. So x equal to mass of gas. That means we can say generally mass of adsorbate. Gas is the adsorbate here. Okay. Then m equal to mass of the adsorbent. Which one is the adsorbent in this case? Solid substance. Okay. So x equal to mass of the gas, that is adsorbate, and m equal to the mass of the solid, that is adsorbent. Then K equal to constant. K and N are empirical constant. Why it is known as empirical constant? Because it is determined based on experiments, not theoretically. Okay. Then P equal to what? Here, which one is having pressure? Gas. Okay. So here P is the pressure of gas or adsorbate. Okay. So here, so X by M equal to K P raised to 1 by N. Clear all the terms. X equal to mass of the gas or adsorbate. M equal to what? Mass of the adsorbent or solid substance. Okay. K and 1 by N. K and N are empirical constant, and P is the pressure of the which one? Gas, that is adsorbate. Okay. So here you can see this is the isotherm, that is the curve, okay, obtained, adsorption isotherm curve it is, okay. So what is the curve? How it is? A plot of x by m against pressure, okay. So if it is checking, the pressure is 0 in the beginning, and if you are moving from left to right, what is happening? The pressure is increasing, okay. And here in this axis x by m it is given. If you are moving upward, what is happening? X by m value increases. Okay, so here you can see first curve is obtained at which temperature? 195 Kelvin, and the second curve is 244 Kelvin, and the third curve is 273 Kelvin. Okay, so from these we can observe one thing. What is that? With decreasing temperature, what is happening? Adsorption increased. That is why at 195 Kelvin, that is the lowest temperature among these temperature, the highest adsorption is happened. That is why which one we got the highest curve or largest curve we got. Okay, and 273 is the highest among these temperature, and at that temperature we got which one? The lowest curve. Okay, so with the increase in temperature, what is happened? The adsorption is decreased. Okay, then with the pressure, this curve is obtained at 273 Kelvin, right? Okay, so from here to here, what is happening? Pressure increases, right? Okay, so with the increasing pressure, what is happening? The curve or adsorption also increases. We know that. Then 244 Kelvin, what is happening? Same thing with increase in pressure, what is happening? The curve is increased. That means adsorption is increased. Then next is 195 Kelvin. That also it is having the highest curve because the temperature is lowest. Okay. So here with increasing pressure, what is there? The adsorption is increased. Okay. Then see after that by taking the logarithm of this equation. Okay, so how I can write the logarithm of that equation? What is the Friedrich adsorption isotherm equation? X by m equal to kp raised to 1 by n, right? Okay, so what is the log? Log x by m equal to log k plus, this is what is that? Multiplication in log, how it is the sum. Okay, so log k plus, this is log x raised to m equal to what? M log x, that is according to logarithm rule. Okay, log something x raised to m means m log x. So here it is like that, p raised to 1 by n. So how we will take 1 by n log p, 1 by n log p. Okay, so what is it? Log k, log x by m divided by log x by m equal to log k plus 1 by n log p. Clear? Okay, so after this equation is in the form of which one? Y equal to mx plus c. Y equal to mx plus c. Same, no? Y equal to mx plus c. Okay, then he plots, Friedrich plot this one, log, there is a plot between log, here it was x by m, right? So here once again he plot log x by m, log x by m, in place of, here it was x by m, right? In place of x by m he took log x by m against which one? Log p. Okay, then he got a straight line like this. Okay, then the slope of this straight line, okay, all of you know how to take the slope. Okay, slope of this straight line, it's got the value 1 by n, slope equal to 1 by n, 1 by n. So we will go, we got 1 by n value also. Then interceptation, extrapolation, that means by extending this line to y axis. This is y axis and this is x axis. Okay, so extrapolation of this one we will get, that means what? Intercept. Which intercept? Y intercept, because we are extrapolating to or extending to y axis, right? So the y intercept we will get which value? Log k. So we got log k also. Okay, so experimentally it is found that the value of n is in between 0 to 1. So what is the value of n? It is in between 0 and 1. It is in between 0 and 1. Okay, so if you are applying the value in this equation I am marking that as 1. Okay, if 1 by n equal to 1, first I will write 1 by n equal to 0, because the value of n is in between 0 to 1. If 1 by n equal to 0, okay, so how we can write this equation? X by m equal to kp raised to 1 by n, I am taking as 0. Okay, something raised to 0 equal to what? 1. Okay, so we will get x by m equal to k. Okay, because p raised to 0 we will get 1, something raised to 0 equal to 1, so x by m equal to k. That means when 1 by n equal to 0, the adsorption is constant. That time what is happening? The adsorption is constant. Okay, then if 1 by n equal to 1, 1 by n equal to 1, so how we can write this equation? X by m equal to kp raised to 1. In place of 1 by n, I am putting 1. Clear? So what we will get? X by m equal to, okay, kp, right? X by m equal to kp. That means, can I write x by m equal to kp means what? This is a constant, right? So can I write x by m is proportional to p? Can I write? Because this term is a constant. Okay, this is a proportionality. We can consider as a proportionality constant. So I can write x by m is proportional to p. So if we are removing this proportionality sign, we can put k here, right? So x by m is proportional to p. That means if 1 by n equal to 1, x by m is proportional to p. That means the adsorption is proportional to the pressure, directly proportional to the pressure. Okay. Then one limitation of this law is he could not, at high, experimentally it is found out that at higher temperature, higher pressure, the adsorption is level reached at a saturation. That means no more adsorption can be happened. Okay, that saturation at high pressure cannot explain by Friedrich adsorption isotherm. Okay, that means Friedrich adsorption isotherm fails at which temperature? Fails at high pressure, not temperature. It fails at high pressure, and it fails to explain what is happening to the adsorption at high pressure. Okay, so clear all of you what is Friedrich adsorption isotherm and the equation. Each terms you have to explain, and the graph, two graphs it is there, that also you have to learn. We are moving to adsorption from solution phase. Okay, that means adsorption from a solution. We know solution means it is a mixture of solvent and solute. Okay, so some solids are having, or some adsorbents are having the ability to adsorb solute from a solution. What is that? Some solid substances are having the ability to adsorb solute particles from a solution, not solvent, solute particles from a solution. Okay, these properties mainly make use in which one? Industry that used to adsorb coloring matter. Okay, that means if you want to change, or if you want to adsorb a color from a solution, we can use this property. Okay, for example, last class already I explained raw cane juice. Raw cane juice is having not white color. What color it is there? Pale yellow or brownish color is there, right? Okay, it can be converted to white sugar. Sugar is white color, okay, by using which process? Adsorption. So mainly activated charcoal is used to color, adsorb the color from which one? Raw cane juice. Okay, then second example is charcoal we can use to adsorb acetic acid and oxalic acid, etc. from the solution. Okay, then third example is litmus solution. Litmus solution means it may be having blue or red color. Okay, so we can make it colorless by using a charcoal. So charcoal, what will happen? It will adsorb the color producing solute from that. Okay, so we will get a colorless solution. Okay, then the factors affecting adsorption from solution is just like the previous factors. Okay, that is, first one is the adsorption decreases with increasing temperature. All of you know adsorption is an exothermic process wherever it is. So it is in solution phase also. Adsorption decreases with increasing temperature. Then second factor is depending upon, it depends on the nature of adsorbent and adsorbate. Depending upon the adsorbate and adsorbent, the rate of adsorption will be changed. Then surface area of the adsorbent. If surface area is more, means what will happen? Adsorption will be more. Then the fourth factor is concentration of the solute. If more concentration is there, the solute in the solution, means what will happen? It will take the more time to adsorption, to complete the adsorption. So what are the main factors? Temperature, then nature of the adsorbent and adsorbate, then surface area of the adsorbent, and the concentration of the solution. Okay, this Friedrich adsorption isotherm can be applied to this also. That means not only for gas and solid, we can apply that isotherm to the adsorption from solution phase. Okay, so we know what is the Friedrich equation. X by m equal to Kp raised to 1 by n. Okay, why we use pressure here means because it was in the previous case, it was what? Gas molecules are adsorbed on the solid substance. Okay, here we are telling about which one? Concentration of the solution. There is no gas molecule, there is only solute and solvent there. Okay, so in place of P, we have to write X by m equal to K Kc raised to 1 by n. What is that C? C is the concentration of the solution. We know different methods are there to express the concentration, molality, etc. So in place of P, we have to change with the concentration because we are using which one? Solution. Then other things, everything is same only. Okay. So we know X is the, there X is the mass of the gas, here X is the mass of the solute. Okay. M is the mass of the which one? Absorbent, but everything is same. Okay, then K and 1 by n equal to constant, right? Okay, then there is a graph plotted between, not like x by m, so we already explained there, so don't want to repeat that one. So he plot a graph between after taking log, first we will take the log. Okay, so log x by m equal to, just like there, log x by m equal to log k plus which one? We know 1 by n log c. 1 by n log c. So what is the graph? There, that one more curve was there in the previous case, that is not required in case of solution. Directly we can go for the logarithm expression. Log x by m equal to log k plus 1 by n log c. Okay, log k is common in both cases. Okay, so 1 by n log c. Then he plot a graph between log x by m in the y-axis against which one here? It was, in previous case it was pressure. So here we are using which one? Log c. Okay. So we will get the same thing, straight line, and the slope will give which value? 1 by n value, and extrapolating to y-axis, that means y-intercept, we will get which value? Log k. Okay, here it is log k plus 1 by n log c. Okay, so that is the application. We know the other things, 1 by n, k, nothing is changed. Okay, so that is about which one? The adsorption of solutes from solution. So clear all of you? Adsorption of solute from solution and its Friedrich adsorption isotherm. We are moving to the applications of adsorption. Many applications are given in the textbook. Okay, so first one is in heterogeneous catalysis. We know what is a catalyst. Okay, catalyst means it is used to increase the rate of a reaction. Okay, so homogeneous catalysis is there, heterogeneous catalysis is there. We will discuss in next class what is homogeneous and heterogeneous catalysis. Okay, so if a catalyst is present in a reaction, what will happen? The reactants are adsorbed on the surface of the catalyst. Okay, so there which process is there? Adsorption. Okay, then second is in gas mask. Okay, so in mask we are using the adsorption. Any adsorbent is there means it will absorb any poisonous producing gas. Okay, then in refining oils and fats, and also for rocaine juice, I told you if any color or anything is present as the impurities in oils, okay, we can adsorb that one. Okay, so they are using suitable adsorbent. Then creating high vacuum means if you want to produce a high vacuum, we can use adsorbent to adsorb the air. Okay. Then in chromatography, we already discussed adsorption chromatography. We were using alumina as the adsorbent. Then to adsorb the moisture, yesterday's class I explained to you, if you are buying new bag and bottles, what will be there? Silica gel will be there, that will act as it will absorb the moisture content present in that. Okay, then softening of water, ion exchange method, that is also using to convert a hard water to soft water. Okay, so that is also ion exchange resins are there, that is also act as an adsorbent. So it will absorb the hardness producing substance from the hard water. Okay, then separation of inert gases. If you want to separate a mixture of inert gases, that means helium, neon, argon, krypton, xenon, etc., if we can use suitable adsorbent to remove them or to separate them. Okay, then froth flotation, we know depressants were using in froth flotation process. Okay, there also which process is there? Adsorption process is there. Then adsorption indicators, we know in lab we are using, in volumetric titration we are using indicators like phenolphthalein, methyl orange, etc., to know the end point. Okay, if you are using adsorption indicators, we can identify to mark the end point in place of other indicators. Adsorption indicators also we can use. Okay. For example, fluorescein, it is an organic compound. It is using as adsorption indicator. Okay. Then in dyeing, that means the dye means we know, no, dye, different colors dyes are there. That dye, DYE, dyes are adsorbed on cloth materials. Then we are getting different color and print, etc. So there also what is their adsorption. Then it is coming cleansing agent. Cleansing agent means for cleaning. For example, if you want to clean a cloth, okay, we are adding detergents or soaps. So what will happen is the detergents or soaps are adsorbed on the interface between is dirt and cloth. Okay, suppose this is a cloth material. Okay, so on that what is the dirt is there, means the soaps or detergents will be adsorbed in between which one, our cloth and dirt. So it is easy to remove the dirt. That also we will explain in next class. It is coming, cleansing action of soap. Okay. Then last one is it is coming in curing diseases. That means if an adsorbed drugs, it will be adsorbed by the germs or microorganisms and they will kill it. That there also which process is there, adsorption is there. So adsorption process is having many applications. Okay, so just to go through it, no need of by hearting any applications. You have to know this process is mainly based on, or this one is mainly based on which process, adsorption. So that's about today's class. Okay, clear all of you today's class. Thank you girls.